Hi, everyone. We are working on Chapter 3, Assessing Significance in a Fourfold Table, Section 3.1, Method 2. And if you remember from the reading, Method 2 talks about when we have a predetermined N1 dot and N2 dot, which means that the group size of the people who are exposed is fixed. So we're going to do a similar example from the book where we have 150 people who are exposed and 50 people who are not. And then we're going to look to see whether or not characteristic B is present or absent. So we're going to create our data set in the regular way. And from here, we have 200 observations and 2 variables, A and B. We're going to reorder the factors so that present comes first and absent comes second. And we can create our regular table of A and B. And we see that right here, where for characteristic A, we have a total of 150 people, 15 people who had characteristic B. And for the people who did not have A, there was 10 people who had characteristic B, 40 people who did not. Now I can just take the sum of the entire table to get our N dot dot. That's our overall number of people in our sample. That should be the 200. And then the NI dot, those are the row sums. So we should get 150 and 50 here. Good. And if we want, we can just define N1 dot and N2 dot by picking off the first element, which is 150, that'll be N1 dot, and pick off the second element, which is 50, using the square bracket. Okay, so we can define N1 dot and N2 dot. And then N dot J, those are the row totals, or excuse me, the column totals. And we use the apply function here on T. 2 stands for columns and sum means we're summing up the columns of T. So when we do N dot J, we get the 25 and 175. And once again, I could pick off the elements of N dot J to describe N dot 1 and N dot 2. So the column 1 sum, N dot 1, is the first element. That should be 25. And the second element of N dot J, that'll give us N dot 2. And that would be 175. And if we double check that, we have exactly what we wanted. Now, PI is the proportion of successes. And in our case, that comes from the first column of T. Remember that the square brackets represent the rows and then the columns. So we're saying take the first row and divide it by the row sum. So if we get PI, we get 10% and 20%. All right. Now, if I want, I can pick off the first element of PI. And in this case, there's no comma because this is just a vector. So this is just saying which element of the vector do I want, whereas T was a data frame with multiple rows and columns, and that's why we're using the comma before. But PI1 will tell us our first proportion, and PI2 will give us our second proportion. Okay. We could also calculate P bar as defined in our book. And we can calculate Q bar, which is 1 minus P bar. So P bar is all of the successes, that's the N dot ones, divided by the overall total of N dot dot. So N dot 1, remember that's telling us all of our successes, and then N dot dot. Okay, so I could create a new table if I wanted that you can also see in the book. Okay, so this table corresponds to table 3.7 in our book, where it shows the number of successes and then the probability of success. All right, if I want to calculate the test statistic in this case, you can follow the formula 3.5 in our book, where it says to take the absolute value of P2 minus P1 And then we subtract off the continuity correction. That's 1/2 times 1 over n 1 dot plus 1 over n 2 dot. And then in the denominator, we take the square root of p bar times q bar times 1 over n 1 dot plus 1 over n 2 dot. Okay, so once again, that's formula 3.5 in our book. And we can calculate the test statistic. We get a value of 1.60. And if we square that value, that will give us our chi-square test statistic value. In this case, it's 2.56. So all of this information can help us get to the p-value. And remember, if we do p chi-square, that is saying for a given test statistic, calculate the p-value on the chi-square distribution. Remember, we've seen stuff like p-binom and p-norm, but now we have a chi-square distribution, so we're using p chi-square. The degrees of freedom are the number of rows of t minus 1, and then the number of columns of t minus 1, and you multiply those together. So since we have a 2 by 2 table, the degrees of freedom will actually be 1. And remember, for the chi-square distribution, it's skewed to the right, centered at 1. And so when we want to find the p-value, we're actually looking for the upper tail. So here I said lower tail equals false because I want the probability of being greater than my test statistic, and the p chi-square formula will automatically default to the lower tail. So I could have done 1 minus p chi-square if I would have left this lower tail equal to true as it is in the default. But instead, I just change the default and it'll automatically give me the upper tail. So for running this, we find that our p-value is 0.1085. And all of this work, we realized that we could have just done a shortcut using prop.test in R. And if we do this, we need the number of successes for each group. So if we check this out, ni dot times pi, here, we have 15 and 10. And then our ni dots, remember, that's the 150 and 50. So if we run prop.test, it will do all the work for us. And you'll see that the chi-squared value is exactly what we got, 2.58. And the p-value is 0.1085. And this gives us our 2 sample tests for the equality of the proportions with a continuity correction. Also includes our confidence interval and gives us the estimates of the proportions. And if we wanted, we could just do names of tests, and that would tell us the information that we could pick off. And we could choose the statistic, the parameter, the p-value, the estimate, the null value, confidence interval, and so on. And so if I wanted to pull off that chi-square value, I could do test $statistic, and that should give me my chi-square statistic, 2.58. And if I would have done test $p-value, I would have automatically gotten the p-value. And there it is. So we did all the hard work to write out all the formulas. But at the end of the day, if you like, you can just directly go to the shortcut and do the t-test that is shown in this section. I hope you learned something in this video, and I will see you guys next time.